All right, today we're going to be talking about solving quadratic equations. Today we're going to be using graphs, tables, and factoring. You should probably read through the vocab, the I cans, the why, and get your graphing technology and have that on hand. And if you have not already completed the warm-up, pause the video and please do that now. All right, what I wanted you to focus in on this first warm-up is this is a quadratic expression. That it is in factored form. What we would do with this is we would evaluate, or we could expand the product. And by expanding, we would end up with our standard form, a quadratic expression in standard form. Here I wanted you to pick up on the fact that this is an f of x equals those same two factors. This is a quadratic function. This is what we have been talking about in topic 3, and it is in x-intercept form. What we would do, or what this is this is the set of all x comma f of x's that satisfy the relation f of x is found by taking an input minus 2 times that same input, add a 5, and multiply them together. The picture of this is a parabola. And what we would do with this is we could, with or without the graph, we could graph it. And with or without that graph, we could identify key features of the graph and of our function. This is something new, number 3. What we will notice is that the f of x is replaced with a 0. I am now looking at a quadratic equation where I have the expression equal to a value. Does not have to be 0, but in this case, we're going to start with looking at the case where we equal 0. What we do with this is we solve equations, right? In this one, we would solve for x. And what we would get are x values that make f of x equal 0. All right, if you haven't done the second warm-up, I'd ask you to go ahead and do that for me now at this time. So pause the video. All right, if there are any questions on those factors, you need to ask them now because that's going to be part of our lesson today is factoring to uncover solutions. We've got to do some vocab. So a quadratic equation is an equation of the second degree What this means is it is a quadratic expression equal to a value or another expression. Today we're going to just stick with the value. The goal is to solve for x or x's that produce the value. So for example, if we have 2x squared minus 1 equals 31, we are going to be looking for the x's that satisfy that equation. Or I could have 2x squared plus x plus 9 equal to 0. I'm looking for the x's that I put in that expression that will give me 0. Make that a minus, actually. Okay, some more vocabulary. So we talked about solving equations. So our solutions are going to be the value or values of our argument. So that's what we're taking the function of. Another way we can think of this is or inputs to our function that satisfy the equation. So if we kind of go back to this one up here, we can see that 2 times 4 squared minus 1 is 31, because I'd have 2 times 16 is 32, take away 1 would be 31, and 2 times a negative 4 squared minus 1 equals 31. So it is possible, now that we have degree 2, makes it possible to have 2 solutions. All right, some more vocabulary. X-intercepts of a quadratic function. These are the x coordinates or the location where the graph, and we know this has got a special name, parabola, intersects the x-axis. We express these as ordered and ordered pair or ordered pairs of the form x1, 0 and x2, 0. The x's here are always real numbers. And when we get to our next lesson, you're going to kind of see what I'm talking about here, that we've got another option. All right, and then finally, the zeros of a function. The inputs or arguments because we could have more than one here, that satisfy f of x equals 0. these x values are not always real numbers. Okay, if we look at the graph, we can determine our solutions to an equation if we have our quadratic set equal to 0. What I'm looking for are my x-intercepts. And we can see that there are two solutions here. I could take -4, square it, and subtract 16 and get 0. I can take +4, square it, subtract 16, and get 0. So the solution is x equals -4 or x equals +4. My x-intercepts I'm going to write as an ordered pair. -4, 0, and +4, 0. My solutions live on that real number line. All right, we may want to use our graphing technology here, although I think we should be able to graph these two pieces pretty easily. On this first graph, I'm going to show you getting the solution using two graphs. Oops, not approach. Okay, I'm first going to graph x squared minus 16. Over 1, up 1, over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3. Let's kind of fill in the rest here. And then I'm going to grab my other one here. X equals 9. That's this line right here. And we notice where these two intersect. Oops. Get rid of that dot. Where these two intersect are my solutions. X equals -5 or x equals +5. And our graphing technology will do this for us. So let's grab that and let's go ahead and put in x squared, take away 16. And then our second graph is going to be y squared equals 9. And we're going to graph it. And I'm not even going to get concerned that I don't see the whole thing here. As long as I see the intersection, I'm good. And then now we're going to use that second trace. But instead of looking for the maximum or the minimum here, we're going to look for the intersection. So we're going to pick number 5. And it's going to ask us some questions. Is the first curve this one here? And to answer yes, we're going to hit enter. And then it's going to say, is this the second curve? And we're going to say yes. And then it's going to want us to guess. We're not going to guess. We're just going to hit enter. And it gives me this coordinate, or these coordinates here, the 5, 9. And then if I do it again, second trace, intersect. And what I need to do is I need to move. So I'm going to arrow over and move closer to the other intersection point so that it doesn't give me the same point again. So I don't even see my cursor quite yet there. I see it moving up the page. This is probably good enough. So now I hit enter, enter, enter. And there's the second intersection point, -5, +9. So we know there's two solutions to this equation. Now, the one graph approach requires a transformation. We are going to transform x squared minus 16 by translating it down 9 units. So now I am looking at solving the equation x squared minus 25 equals 0. So now this is the only graph I'm going to put in my grapher. I don't have to put 2 and look for an intersection. I'm going to put in 1 and look for zeros or those x-intercepts. So I have x squared subtract 25. And I'm not even going to care that I don't see part of the graph because I know it goes all the way down here to 25. What I'm interested in are the x-intercepts, and they're at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's same, positive, and negative 5. In general, we're going to use the one graph approach or transform our quadratic so that it's equal to 0. And we're just going to take a quick look at, here's the scenario here. We had 2 solutions to our equations. Here we have exactly 1 solution. And this one is real because it's on my real number line. The solution here is x equals 7. Here I have no x-intercepts. There's no intersection between my parabola and my x-axis. So here I do have solutions, but the 2 solutions are not real, and you'll have to tune back for the next lesson, tune in for the next couple of lessons to figure out what exactly they are. So if you're going to take a few minutes to summarize and reflect on kind of what we talked about. All right, there's a couple here for you to try, so I'd like you to pause the video